Hi everyone, it's Sorkan. Today we have a problem when we are given an array of characters and we need to compress our array of characters and return the size of the new compressed characters. So for example, in this case, we are given A, B, B, C, and the C, and how we are going to compress that. So we are going to first store the character and how many times it's repeated. The A is repeated twice, B is repeated also twice, and the C is repeated 3 times. So the size of our new compressed characters is equals to 6, which we are returning here. So how we are going to solve this problem? We are going to solve this problem with our approach is pretty straightforward. So let's say we have this one, right? So A, B, B, C, C, and C. So what we are going to do, if the character is repeated once, then we are appending only the character to our S. So which means that to our new compressed characters. So we are first adding A is repeated only once, B 2 times, and the C is repeated 3 times, and we are returning 5. So one important requirement is that our solutions should be constant. Our solution should be constant. We should not use any extra space. So for example, in this case, we should not create any new characters in order for counting our characters, right? So for counting our compressed characters. So how we are going to do that? So we are going to use our initial array. So for example, for this case, let's say, right? So we are going to count first 2 adjacent elements. So we are comparing A and A. A is equals to A, so which means that the A size of the A is equals to 2, right? So the A is not equals to B, so here we are first storing A, right, in the first one, and in the second one we are storing how many times it's repeated, 2. So the next one is we are comparing B with B. B is equals to B, and the B, again, we are incrementing this number of times B is repeated to 2. B is not equals to C, so we are again storing here B, and it repeated twice. The same we do for the C. C we will compare with the C, and its size of number, it's repeated 2 times, and the C is equals to the next C. Again, the C is repeated 3 times, so we are storing C, right? We are storing C, and how many times it's repeated. C is repeated 3 times, and what we do is this is the size of our new compressed characters. So we are returning this index, which will be the size of our new compressed characters, right? The index of this is equals to 6, so we are returning 6 because it's the size of our new compressed characters. One more important requirement here is that let's say that we have A, and let's say B is repeated 20 times, right? B is repeated 20 times, and we have C. So in our characters, right, we need to store them as 2. So in our let's say that if in this case B is repeated 20 times, not 2 times, B is repeated 20 times, so we need to store them as separate characters. So in our final array, right, we are going to store array of characters. We are going to store A, we are going to store B, we are going to store 2, and we are going to store 0, right? Because B is repeated 20 times. Since B is repeated 20 times, we are storing A, B, 2, 0, and we are storing C, 2, right? And then the size of our final characters, compressed characters is 1, 2, 3, 4, 5, 6. So 6, which we are returning. Okay, first thing that we do here, we are checking that if the characters are empty, then we are returning 0. The next one is that we are initializing 2 variables, index and I. So I we are going to use in order to go over our array of characters, and then index we are going to return as that would be the size of our new compressed characters. So what we do is we are taking the current character and we are creating one more variable count, and we are setting the value of that to 0. So we are moving our I and incrementing count until our current character is equals to character, whatever the character I is. So for example, in this case, let's say that we have a A, B, B, and C, 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 right? So we are going to move our I and our count until our A's are equal. So until the two adjacent characters are equal. And after that, once we exit this for loop, so we have our character and we have the how many times it's repeated, right? So first we are storing our character and we are increasing our index because we have already used the one index, right? And the next one is we are checking that if our count is more than 1, because if it equals to 1, then it means that we are storing only character, right? If it's more than 1, which means that we need to also store how many times that character is repeated. So we are going over our count and we are storing each digit, right? So as we have seen in the example earlier, if the A, for example, if the A is repeated 20 times, then we have to store 2 and increment our index, and we have to store 0 and increment our index. At the end, we are just returning our index, which points to the size of our new compressed characters. So the time complexity of this solution is of n, because we are going over our list only once, and the space complexity is by requirement constant, it's of 1. Java implementation is identical to Python, so what we do here, first we are checking that if our character is equals to null, or if the characters are empty, then in that case we are returning 0. Then we are initializing two variable, index and I, and we are going over our characters. So we are taking the current character and setting that our count to 0. So we are going until our character is equals to our current character. So for example, in this case, right, let's say that we have A, and we have B, and we have C. So we are going to until let's say that this character, first character, right, is equals to all other consecutive characters. So then we will move our I pointer until I is less than our length of our characters, and it equals to whatever the characters is in I. So once we exit this for loop, first thing that we do is we are setting our characters and incrementing our index, and we are setting our current character to the characters and incrementing our index. And if our count is more than 1, if it's equals to 1, so what it means that we don't need to store how many times it's repeated by requirement. If it's more than 1, then we are storing each character. So for example, let's say if A is equals A repeated 20 times, 30 times, or whatever, then in that case we are first storing 3, let's say 30 times, right? Then we are storing 0 and we are going to the next character. At the end, we are returning the index, which points to the last index that we have stored, and which means that the next one will be the size of our new updated characters, compressed characters. Okay, that's it for today. Hope you like my content. If you like it, please hit the like button and subscribe my channel. See you next time. Bye.